Hello guys, welcome again. My name is Stephen Miti. I'm a 5th year student in the School of Electrical Engineering at the University of Zambia. So this is my video and I'm mainly focusing on the solving nonlinear equations using numerical method. Okay, so specifically I'll be looking. It's my first video. And of course, this is not my first video on YouTube, of course. I've created so many videos, about 20 of them. So, and most of them are on numerical analysis. So please don't forget also to subscribe and also share with your friends. Yeah. So I hope you enjoy my videos. If you do, please don't forget to share with your friends and also subscribe to my channel. Okay, this one I'm starting. Okay, but I promise guys, things will be better soon. Yeah, you get to enjoy. Yeah, so please support me by just subscribing, like, share with your friends, and also comment. And of course, don't forget, okay, if you disagree with what I was doing in the video, okay, how I solved it, or maybe the method is wrong, don't forget to share your views or your ideas. Okay, just comment in the just drop a comment in the comment section. I'll be able to read all the comments you guys will be sharing. Okay, so this is our second topic in numerical analysis. Okay, so today we want to look at solutions of equations in one variable. Okay, how can we find the solutions of equations? Okay, in one variable using the numerical analysis. Okay, so in scientific and engineering work, a frequently occurring problem is to find the solution of equation of that form. So we know by now that if you have a quadratic equation, you know how to solve. You can either use a quadratic formula, or use completed square, or maybe factoring method. Okay, you'll be able to solve finding the values of x, or those are the roots, we call the roots. Okay, so that if you substitute in that equation those values, you get the value of the equation equal to 0. Okay, so now how can we solve a problem using numerical methods? Okay, so solutions of that equation are called roots or zeros of the function. Okay, so this equation, you see that's equal to 0. So the solution for this guy, they are called what? Roots. So if f is a quadratic, cubic, or biquadratic expression, then algebraic formula are available for expressing the roots in terms of the coefficients, just like I explained. We have different algebraic equations that are available. Algebraic method. Okay, so on the other hand, when f is a polynomial of high degree or an expression involving transcendental function, algebraic methods are what? Algebraic methods become what? Are not available. So in this chapter, we'll describe some numerical methods for finding the roots of that equation. Okay. Just a minute, let me just move this. Okay. Okay. So the first method you're going to look at is called bisection method. Okay. So this bisection method involves, okay, first of all, for us to use this bisection method, we have to know the interval in which that root can be found. Okay, so for instance, you have a quadratic equation. I'm just going to give an example. Let's have a quadratic equation. Okay, x squared plus 3x plus let's say is equal to let's say 7, right? Okay, so we're going to write this equation in terms of what? As a function f of x and has to be equal to 0. So how can I write this equation in terms of f of x equal to 0? You're just going to move that 7 to the outside of the equation. Okay, x squared plus 3x minus 7 equal to 0. So you will notice that for this equation to be equal to 0 to be true, we need to find the values of x. Okay, we need to find the values of x that we're going to substitute in the equation to in order for this equation to be equal to 0. Okay, so now those values that we're looking for are called the roots of the equation, or the zeros of the equation or the function. Okay, so every time the function crosses the x-axis, okay, every time the function crosses x-axis, at the point where the function is crossing the x-axis, that point is called its root of the root of the equation, or the zero of the equation. So you may have a function, okay, something like this. This function is f of x. This function crosses the x-axis at point P. Okay, so this P here, P is the root of the equation, because at that point, if you substitute this P in the function, we are getting the function equal to 0. So this P is called the root of our function. Okay, so now using bisection method, we need to find this root here. Okay, so this root here can be found by the first method we have here is called the bisection method. So we need to identify first the interval where this root lies. Okay, so the interval can be, let's say, from A up to B here. Okay, so we are looking for the root in this interval, which is A, interval from A to B. So the root is somewhere within this interval here. So we're going to use the iterative methods to find or to approximate this root, okay, in this interval. So this is what bisection method is involved. So I'm going to take you through some of the steps that we need to apply every time, only the steps we need to follow every time we're applying the bisection method. Okay. So use the iterative methods to find or to approximate this root, okay, in this interval. So this is what bisection method is involved. So I'm going to take you through some of the steps that we need to apply every time, only the steps we need to follow every time we're applying the bisection method. Okay. So let me just do this. Okay. So I think for the better understanding, I'm going to look at an example. I'll explain everything by using an example here, okay? Because for people to understand, I think the example is the best, okay? Okay, let me just share the board. So I'm going to leave this, okay. All right, so here's the board. Okay, so we are trying to use bisection method. So this is called the bisection method. Okay, so under this bisection method, we are using it's an iterative method, of course, okay? When you are solving the quadratic equation or whichever kind of equation that you have, be it a cubic function, okay? So the first thing here, remember that the goal is to find P, okay? We're not finding the root, okay? Finding the root. The root, which is P of an equation. And we need to be given the interval. So the interval is from A to B. So this root lies in this interval A to B. So somewhere in between here. Okay. So if you have a function, if you substitute this P here in the function, this function must be equal to 0 or approximately equal to 0, since we are using the numerical method here. This P may not be exactly, so it will not be exactly equal to 0, but it will be somewhere close. Okay, so now how do we find this P here? Okay, so Wow, how we find this P here, we use what we call a bisection method. Okay, so this bisection method says that if the interval here, okay, if you have the interval here, you can find the initial value of P, and this P, I'll call this P naught. Okay, so this P naught will be equal to, you add the values A plus B. Okay, sure, no problem. So A plus B divided by 2. Okay, so what is A? A is the value which is given in the interval, and also B is the value given in the interval. Okay, so once you find this P naught, you substitute in your function. Okay, so you're going to have f of P naught. Okay, f of P naught, and you are going to get another value, say K. Okay, when you substitute this f of P naught, you get a value K. And now the next thing you need to identify is the sign of this K here. Okay, the sign of this K, is it positive or negative? So if K is positive, or sorry, it's negative. If K is negative, okay. Okay, I forgot to tell you something first. Every time, I think I need to restart this. Let me just restart this guy. Okay. Just to edit this video. So every time you're using the bisection method, here are the steps you need to follow. Okay. So the first thing, of course, you'll be given a function. Okay. And make sure that that function you write in this form equal to 0. The second thing, of course, you'll be given what? An interval. This interval is where the root lies. Okay. An interval A to B. Okay, the next thing now is to test this interval. Remember that, okay? Let me just draw a graph here, a function, okay? So this is x-axis, this is the y-axis, okay? All right. Let me just say, okay, I have a random function, right? Okay, this is a random function. This function is f of x, okay? And then it crosses the x-axis at p. So at this point here, the function is crossing the x-axis at p, which is a solution to this function, okay? That's a solution, isn't it? So now, and then that p lies in the interval from A to somewhere B, okay? We know this, right? And if you notice, this A has a corresponding value, okay, of the function where this, okay, so if you substitute A in the function, you're going to get some value, which is, I would say this K1. And also at a point when X go to B, you also get the value, okay? And that value, I'll call it K2. And if you notice, these two values, K1 and K2, have different signs, right? Okay, K1 is negative, K2 is positive. So this tells you that for the function to have a root in a given interval, there must be a change of sign, isn't it? Okay, because if the sign still remains the same in a given interval, then it means that there is a possibility that function hasn't crossed the x-axis yet. Okay, but yeah, there might be some situations. Okay, there might be some situation. Let's say you have a function that looks like this, right? You may be cheated sometimes, right? But those situations are very rare. Okay, unless specified. You may have a function that looks like this. What if the interval is so big, right? Let's say the interval is from A to B. We have this interval here. Okay, you notice that in this interval you have two. You may not be able. Okay, you may not be able. You may be like cheated, saying, okay, the function doesn't cross the x-axis in this interval because
at this point A, you notice that you are getting the positive values of value of y. Similar at point B, you're also getting the positive value of y, right? So we say, okay, there's no root in this interval. But if you notice, actually the function crosses the x-axis twice, right? Okay, but on that, the interval that you have taken, okay, it's so big, okay? Within that interval, the function is able to cross the axis twice. So the only thing that you've captured is the positive part of the function. Okay, but if you reduce the interval, let's say the interval, let's say, comes here, okay, B moves to this position, you notice that you're going to have a negative value of y at that point, right? So you'll be able to capture this root here. Okay, anyway, that's not part of the discussion. But most of the times you're going to have such questions like where you just have one value of P in that root. Okay, so now, so since I've mentioned this, there's a change of sign. There must be a change. There must be a change of sign for that function to have a root in a given interval. So you have to check now the interval. Okay, you have to check the interval which is given to you. There must be a change of sign. That's when you conclude that okay, there is a root in the given interval. So the first thing you have to substitute a. Okay, you have to substitute that a in the function and observe the sign. Okay. When you substitute, please observe the sign that you get. Observe the sign. Very important. Okay. And also substitute B, f of B, and also you find the value. So this one says K1. Okay, so I'll say this is K1, and this is K2. Also observe the sign. Okay. All right. So if the product of f of A times f of B is less than 0, meaning that, what's the meaning of that? The meaning of that is that if like you substitute one of these values, right, A or B, one of them is giving you negative, the other one is giving you positive. They have different signs, okay, opposite signs. And then there is a root in that interval, okay? Then there is a root in the given interval. Okay, so if the signs are different, then there's a root in the given interval. And if, okay, f of A times f of B, you get something which is greater than 0, positive value, then there's no root, okay? No root. No root in the interval. Okay, so that's how I can conclude. So meaning that if f of A gives you positive value, f of B again gives you positive value, or f of A gives you negative value, f of B gives you negative value, then means that there's no root in that interval. Okay, but one of them must have a negative or the other must have a positive value. Then there is a root in the interval. It means that the function crosses the x-axis in that interval. Okay, now having concluded those, now you have to find that root. Okay, if this is true, you've concluded that, okay, there's a root in the interval. Now here's a next step you need to take. Okay, so you are given the interval, right? Remember that you have the interval. Given the interval, okay, the interval is between A and B, right? So the first thing, find the first root. Okay, remember that we are using bisection method. Okay, so bisection method, you have to find the midpoint of the given interval. So this one I'm going to call it P naught. So P naught will be equal to A1. So I'll call this A1 because they are starting values of A, or I'll call them A naught. Okay, A naught plus B naught. So the starting interval that is given, you can call it A1 B1 or A naught B naught. It's okay, and then divide by 2. So you're going to get the value here, okay? So the next thing, you're going to test this P naught as well in the function. So you substitute P naught, the P naught that you're going to get by dividing the sum of A naught and B naught, you test it. So f of P naught, and you check. is this f of p naught greater than 0 or equal to 0? You decide from here, right? So if, for instance, f of p naught is greater than 0, it's positive in simpler terms, right? Okay. Then you check the previous testing you did. Let's say, for instance, when you tested f of a, let's say f of a, when you substituted f of a, you found something greater than 0. And then we substitute f of b, initially you found something less than 0, right? What you're going to do here, since now you have f of p naught, right? F of p naught is greater than 0. So it means that what you had in your first, when you tested first, what you had was something also greater than 0. You have to discard it, okay? Okay? You are going to consider the new value. So meaning that p naught is going to replace a, because a, after substituting a the function, you got a value which is positive. So meaning that your new interval, becomes what? So in place of, depending which one is bigger between b and p naught, so in place of a, you're going to substitute what? P naught. That naught is going to take the place of a, comma, a b, right? Okay. You get to understand when we look at an example here. So therefore, the new interval now becomes p naught, comma, b. Why p naught? Because p naught, when you substitute p naught in the function, you get a value which is given as 0, which is positive. And also a also had what? Given as a positive value. So it means that we're going to update this interval by substituting the new value of p naught. Okay? And then meaning that you're going to get p1. Okay? So the next, you need to find p1. So p1 now will be equal to the new interval, which is p naught plus b divided by 2. And once you find that p1, you go back and substitute this in your function, f of p1, and you check. Let's say, for instance, now f of p1 is giving us negative. Okay, let's say after substituting p1, we get a negative function value, right? Let's say it's less than 0. Now you go back in this interval, the previous interval that you just made, you check, okay? Remember that f of p naught had given us a positive. F of b, okay, f of b had given us a negative initially. You see this one. This guy had given us a negative. And this one, f of p1 again is giving us a negative. It means that we are going to substitute that. So this b1 will be now replaced with p1. Okay? So meaning our new interval therefore becomes p naught, comma, p1. Okay? And also next we're going to find p2. So p2 will be equal to p naught plus p1 divided by 2. Okay? And again you test it. Okay? You're going to test it, so on and so forth. So for you guys to understand this, I am going to look at one example. Okay, I'm sure one example will make you understand what is actually going on here. Okay, so let me just look at this. So this is example number 1. Okay. Okay. Okay, just a minute. I'm trying to share an example. Okay, so here's an example. Okay, so example says find the real root of the equation, okay, in the given interval, which is 1, 2. So we're given the cubic function. Okay, we are given the cubic function. So we are given f of x equal to x cubed minus x minus 1, and this is equal to 0, of course, okay, equating this to 0. And then I'm given the interval, okay, so the interval, I'll call it I, is equal to 1, from 1 to 2, okay. So first, remember the procedures, first test the change of sign, okay. So change of sign first. We have to test the change of sign for that given in that given interval. So our A is equal to 1, while our B, so I'll call this A naught, right? And this is B naught is equal to 2. So let's test f of A naught, right? Which is same as what? F of 1. We substitute 1 in the given cubic function, 1 to the power 3 minus 1 minus 1. You see this is just equal to negative 1. And you can see that negative 1 is less than 0, okay? And then also we test f of B naught. This is equal to f of 2. So this is 2 to the power 3 minus 2 minus 1. And this is equal to 8 minus 3. And that is equal to 5. And 5 is greater than 0. So you notice that since there is a change of sign, you can conclude that there is actually a root in that given interval. Okay, there is a root in the given interval due to the change of sign. Okay. All right. So you see that 1 is giving us a negative value, while 2 is giving us a positive value. So now we can now find our first value of P. So this will be my P naught. So P naught will be equal to A naught plus B naught divided by 2. So remember that our A naught is simply 1. B naught is 2 divided by 2. This is 1.5, okay? Okay, so we test this 1.5. Let's test it. So we have f of P naught. Now we're going to substitute this P naught in our function. So we have f of 1.5. So this is same as 1.5 to the power 3 minus 1.5 minus 1, okay? So if I use my calculator here, okay, let me try to use my calculator here. Okay, oh, where is it? Okay, so I have 1.5 to the power 3 minus 1.5 minus 1. I have 0.875. And this 0.875, you see that's greater than 0. Okay, now I say, wait, I need to find a new interval. Okay, I need to get a new interval. So now, how do you get a new interval? So a new interval now, you're going to check from the previous interval, the behavior of the previous interval. Okay, remember that A naught gave us a negative value, okay, for the function, or B naught gave us a positive value. Okay, now here we have P naught. So we have a new one, right? P naught is also giving us a positive value. So meaning that in our new interval, okay, our new interval now, so I'll call this as I1. The first one, I should have named it I naught. Okay, this is my first interval. My new interval, this is my I1. My I1 now be equal to, okay, let's see what we're going to have. This guy is positive, okay, f of P naught is positive, so meaning that and also from the previous one, okay, f of B naught was also positive. They are both giving us positive, right? Okay, you see that 2 and 1.5, they're both giving us a positive in this function. So meaning that we have to update the interval. Okay, so 2, we're going to get it over 2. Remember that we're trying to reduce this interval, right? We're making it as small as possible. Okay, so we are going to, instead of writing a 2 here that gave us a positive, we are going to replace that with a 1.5, which is P naught. Okay, so this will be P naught. Okay, for the negative part, we're going to maintain it. Okay, because remember that the interval always has to give us a function for both positive and negative values. So this A naught. Okay, this A naught will be maintained. Sorry, not B naught. B naught is the one giving us a positive, right? So sorry. B naught is one giving us a positive value. So we are going to, so if you look at that, okay, A naught give us negative, B naught giving us positive, P naught giving us positive. So it means in place of B naught, I'll replace it B naught, okay? And then A naught is to be maintained, right? So that my new interval will just be equal to, A naught is what? It's 1. Our P naught is 1.5. So this is my new interval. Okay. Next, I need to find P1. Okay, the next root. So P1 now be equal to the new interval, A naught plus P naught. And divide by 2. Okay. So this will be equal to 1 plus 1.5 divided by 2. So this is how much? Okay. Obviously, this should be 1.25, right? If I get my calculator here, should be 1.25. Okay, 2.5 divided by 2, right? Okay, that's 1.25. So this is my P1. Now I'm going to substitute this P1 in my function, right? So f of P1, which is f of 1.25 equal to 1.25 to the power 3 minus 1.25 minus 1, right? So I'm going to what? I'm going to find how much that one is. So this give me about negative 0.296, right? And this is less than 0. Okay, this is less than 0. So what's the meaning of this? So my new interval now just be my I2. Okay, now I'll check the previous interval. Remember that the previous interval, this one, which is A naught. A naught gave us a negative, right? Remember that one gave us a negative here. Okay, and the new value, which is a P1, is it P2, sorry, has given us a negative again. So it means I have to update this one now. Okay, we have to update it. Okay, so meaning that in place of A naught, okay, in place of A naught, I'm going to replace it my P1. So A naught will be replaced by P1. Okay, because that one is giving us a negative, isn't it? Okay, so I'm going to have 1.25, right? And then comma 1.5. That positive part is still there. Okay, the value giving us a positive to still be taking its place, right? Don't be displaced, because this one we're giving us a negative displace A naught, which is 1. Okay, so we have our new interval now. Okay, which is I2. So from this we can also find the I3. So I3, sorry, not I3, P2. So P2 will be equal to 1.25 plus 1.5 divided by 2, right? So let's also find the half of that. So this is a 1.75 divided by 2. Oh, sorry, 2.75 divided by 2. So I have 1.375. Okay, and also I'm going to substitute this 1.375. So this will be f of P2 or f of 1.375. Okay, and this is equal to 1.375 to the power 3 minus 1.375 minus 1. Okay, so let's see. Okay. So I'm getting a positive value, okay, which is 0.224. And this guy is greater than 0. Okay, now I'll check my interval, my previous interval. this 1.25 was giving me a negative, so I'll maintain it. But 1.5, remember that was giving us a positive, right? So this one will be now be updated, okay? Will be replaced by the new value, okay, which is what? 1.375. So my new interval, which is I3, will be equal to 1.25, comma 1.375. Okay, so this will be my new interval. So since here we're not told about the stopping criteria, when are we supposed to stop? You can continue, so on, so forth, okay? You can do as many iterations as you can, as you want, okay? Let me do two more, okay, two more iterations. So I'm going to find now the new value of P. So I'll call this P3. So P3 will be equal to this new interval 1.25 plus 1.375 divided by 2. So 1.25 plus 1.375, and then divide by 2. I have 1.3125, right? Okay. And again, I'll substitute this 1.3125 in my function. So f of o, 1.3125. Let's see. So I have 1.3125 to the power 3 minus 1.3125 minus 1. Okay. So I'm getting negative 0.0515, and this is less than 0. So now again, you can see what's supposed to do. Okay, you know what's supposed to do. See, this is negative. Okay, this is negative. It means that from this interval, remember that 1.25 gave us a negative, or 1.375 gave us a positive, right? So the negative one now will be displaced by a new value, which is 1.3125. Okay, so meaning that my new interval, okay, my new interval therefore will be equal to, okay, 1.3125, comma 1.375. Okay, so this is my new interval. I can find P4 from this. So P4 will be equal to the midpoint of these two, 1.3125 plus 1.375 divided by 2. Okay, so again, 1.3125 plus 1.3175, okay, divided by 2. So I'm getting 1.315, okay. And then I'll substitute this f of 1.315. Okay, this is the 1.315 to the power 3 minus 1.315 minus 1. Okay. So this is negative 0.041, something like that, and this is less than 0. So you see that again, this guy is less than 0, meaning the new interval, my new interval will be equal to what? Which is, I'll call this my I5. Okay. My I5 will just be equal to the new value. Remember that this 1.3125 gave us negative, and also 1.315. This one is also giving us a negative. So it means that our new interval will be, comma, 1.375. Okay. And then I can also find my next P. And I'm sure you've even seen the pattern, right? Okay. Divide by 2. Okay, so 1.315 plus 1.375. Okay, divided by 2. So I have 1.345. Okay, and I can substitute this 1.345 in my function. So I have 1.345 to the power 3 minus 1.345 minus 1. Okay, so this answer to the power 3 minus so minus 1. So I'm getting a positive 0.088138. Okay, so now again, since this is positive, okay, it's greater than 0, so it means that 1.375 now be displaced, right? Remember that that was a value that gave us a positive in the previous iteration. So meaning my new interval, okay, is equal to 1.315, 1.345. So I'm sure I can say that you can continue and continue, so on and so forth.